Good morning, everybody. Today we're starting 8.4, and this is using scientific notation. So what scientific notation is when it's in the form c times 10 to the n. So our c times 10 to the n, let me just change my color of my pen here. So it's going to look like this, where 1 is less than or equal to c, which is less than 10. So our number could be 1 all the way up to 10, but it cannot be 10, so it has to be less than 10. And n has to be an integer or a number. So if we look at these numbers here, we have 2 million in standard form. It looks like the number you would see, 2 million. In scientific notation, though, it's 2 times 10 to the 6th. Now it's 10 to the 6th because there's 1, 2, 3, 4, 5, 6 zeros, or there is 6 spaces between our decimal point, our imaginary decimal point, and 2. So 2 times 10 to the 6th. Now, our second number is 5 thousandths. And 5 thousandths looks like 0.005. Now that in scientific notation is 5 times 10 to the negative third power. Now it's negative because we're going backwards from our decimal point 1, 2, 3 spots, because remember our number needs to be between 1 and 10. So let's try some of these. So we need to write these numbers in scientific notation. So when we're writing numbers in scientific notation, what we have to do is imagine there's a decimal point. If we have a big number, like we do here, we're going to imagine there's a decimal point at the end, because there usually would be a decimal point at the end, and it would be 0.00 or something like that. So what I'm going to do is I'm going to put this decimal point at the end, and I'm going to count how many spaces I can get before I get to a number between 1 and 10. So I'm going to go 1, 2, 3, 4, 5. Now if I ended there, I'd have 425.9, and that's not less than or between 1 and 10. 42 is not between 1 and 10. 4 is, though. So what I'm going to do is I'm going to write 4. Now our new number is 4.259. I always want to write all of my numbers that I have times 10 to the whatever, how many spaces I jumped. So I jumped 1, 2, 3, 4, 5, 6, 7 spaces. So 4.259 times 10 to the 7th. Next one, I'm still going to imagine there's a decimal point at the end. And I'm going to move 1, 2, 3, 4, 5. Oh, hold on one second. 1, 2, 3, 4, 5, 6. 6 spaces to get a number between 1 and 10. And that number is 3.412 times 10, we always are multiplying by 10, to the 6th power. Here we already have a decimal point, but this time we need to find a number that's between 1 and 10. 104 is what it says right now, so I'm going to move my decimal point 1, 2 spots over, so I can get a number between 1 and 10. So then my answer would be 1.0425 times 10 to the second power. Finally, I'm going to imagine there's a decimal point here. Move over 1, 2, 3, 4, 5 spots. So I'd have 4.1562 times 10 to the fifth. So I moved over 5 spaces. Next we have small numbers, very, very small numbers. So this time we're going to use negative exponents. So we already have our decimal side, but this time we're going backwards. So I'm going to go backwards until I can make a number between 1 and 10. So 1, 2, 3, 4, 5. 4.56 is between 1 and 10. So it'll be 4.56 times 10 to the, we jumped 1, 2, 3, 4, 5 spaces. If we went backwards, it becomes a negative and 5 because we jumped 5 spaces. Next one, we're moving 1, 2, because if we put a decimal point there, we have 8.104, and that's between 1 and 10, times 10 to the second, negative second power, because we went backwards. Alright, I want you guys to try these last two on your own. Once you're done with that, you can move on to the next slide, where we have to write the numbers in standard form. So, standard form, we're going to take our number 2.0075, and this says 10 to the sixth. Now, we know that if it's a positive number, we were going forward if it was already a big number. This time we're going to go backwards so we can make a bigger number still. We're going to go backwards 1, 2, 3, 4, now 5 and 6. We can put a 0 here and a 0 in there. So our new number is now 2, 0, 0, 7, 5, 0, 0. Now if I were to see what number this is, I would have 2,007,500. Here we have 1.685 times 10 to the negative fourth. So if it's a negative, now we're trying to write it in standard form, so we're actually going to move forward now to make it a small number because we have a negative 4. So I'm going to move 4 spaces, 1, 2, 3, 4, and I'm going to fill those spots in with zeros. So what we're going to have is 0.0001,685. Here we have a negative exponent, a negative 5. So again, we're making a small number. We're not trying to make a big number. This one we're moving over 1, 2, 3, 4, and one more, 5. So we'd have 0.0000, 4 zeros, plus the 7 where we moved over, then 0, 0, 1, 2, 3, 5. This one we have a positive exponent, so we're going to move backwards so we can get a big number. If we move backwards 1, 2, we run out of numbers, but we need to move 7. So I move 2, we're going to add just 5 zeros on there. So 4, 5, 0, 2, 1, and then 1, 2, 3, 4, 5 zeros. So this one is actually 4,502,100,000. Alright, what I want you to do is try these ones on your own. Remember, negative numbers, negative exponents, we're trying to get a smaller number. Positive exponents, we're trying to get a large number. So remember which way to move your decimal point. Alright, now we are completing these statements using less than, greater than, or equal to. So our first number is 404,000.1. So that's 404,000.1. We need to see if 4.04001 times 10 to the 5th is the same, less than, or greater than that number. So what I'm going to do is I'm going to rewrite 4.04001, and I'm going to move my decimal point backwards 5 spaces. 1, 2, 3, 4, 5. Now when I do that, I come out with a new number, 4.04001. My decimal point would be there. This comes out to 404,001. So our symbol then would be, I want the greater one, which is this one. 404,000.1 is less than our right side. Here again, we have this smaller number, 0.003309. I'm going to take my 3.309 and I'm going to move it 3 spaces, move my decimal point 3 spaces so I can get a smaller number because it's a negative. So negative 1, 2, 3. So my new number is 0.003309. The first number was 0.003309. These two are exactly the same number, so they are equal. Last one. I have 604,589,000 something 6.04589 times 10 to the 7th. So I'm going to write 6.04589. What I'm going to do is move that backwards 7 so I can get a big number. So 1, 2, 3, 4, 5, 6, 7. Put 2 zeros in there. So it'll be 6, 0, 4, 5, 8, 9, 0, 0. Put my commas in here. And I only get 60,458,900. So this time, that one is, the first one is greater than my scientific notation one. Alright, here we're ordering them from least to greatest. So what we could do is we could write these all in standard form. This one, it looks like it might be easier to write it in standard form because we already have 2 of them in standard form. So I'm going to write 7.8 and I'm going to move that 8 spaces. So 1 and 7 zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. So we have that number. We have 1, 0, 3, 400,000, and 80,760,000. So, least to greatest. Well, we know that the 81 is already the least because that's not even in the 100 millions. So that's our least, number 1. Number 2 is our second one, or our middle one. And then our first one, or the middle one on the top, was our greatest. So this, if we were to put this up here, this would be 1, this would be 2, and that would be 3. Now down here, we have 2 in scientific notation and 1 in standard form. So what we could do is we could write them all out. So I think that way is easiest. So I'm going to go 2.7. I'm going to move that 1 and 1, 2, 3, 4 spaces. Then 3.401. Move that 1, 2, 3, 4 spaces. And finally we have just 27,500. So we have the first one as 270,000. We have 34,000, and we have 27,000. 27,000 is going to be our least, followed by the 34,000 and the 270,000. So this is our least, this is our second least, and our third least, or our greatest. Alright, now these problems are a little bit bigger. It's just multiplication. So what we're going to do is I just want you to put this into your calculator. So I'm going to put the first one in, 8.5 times 10 to the second times 1.7 times 10 to the 6th power. That gives me a gigantic number. It's 1, 4, 4, 5, and 1, 2, 3, 4, 5, 6 zeros. Now it says to write our answer in scientific notation. So I'm going to put a decimal point there and go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So we'd have 1.445 times 10 to the 9th. Next one, we have 1.5 times 10 to the negative 3rd power. All of that to the 2nd power. So what our calculator will show is 2.25 e to the negative 6. Now what that e means is basically just the same thing as our 10. So we could just write this again as 2.25 times 10 to the negative 6th. The calculator puts that e on there because it's too big of a number for our screen to show. So it just puts the e in place of the 10, and they're basically the same thing. Next one, 1.2 times 10 to the 4th power divided by 1.6 times 10 to the negative 3rd power. In our calculator, we will get 7,500,000. That in scientific notation, well, I'm going to move my decimal point 1, 2, 3, 4, 5, 6 spaces. So 7.5 times 10 to the 6th power. Alright, I want you to do these problems on your own. Remember to just put these in your calculator and see what you get. Remember to write your answer in scientific notation. Alright, so it says Oregon has an area of approximately 2.52 times 10 to the 5th square kilometers. In 2000, the population of Oregon was approximately 3.42 times 10 to the 6th people. How many people were there per square kilometer in Oregon in 2000? So, what we're going to do is we are going to take the amount of people, 3.42 times 10 to the 6th power, divide that by the number of square kilometers there were, 2.52 times 10 to the 5th power. That should show us how many people were in each square kilometer. So I'm going to put that in my calculator. 3.42 times 10 to the 6th power divided by 2.52 times 10 to the 5th power. And we get about 13.57, and then I'm just going to round it off there. It's about 13 people per square kilometer. Last one says the images on a computer screen are made up of more than 5,000 pixels or dots per square inch. How many pixels are on a computer screen that measures 108 square inches? Write your answer in scientific notation. So, we know that in 1 square inch there are 5,000 pixels. So 1 square inch, there are 5,000 pixels. And we know that the screen measures 108 square inches. So what we're going to do is take that 5,000 and we're going to multiply it by 108. So 5,000 pixels times 108 square inches gives us 540,000, which is 540,000 pixels. In scientific notation, though, that answer is 5.4 to the 10, or times 10 to the 5th power.